How's it going, guys? So today we're talking about tree diagrams and compound events. Now these are two kind of separate things, but we're going to smush them together because they kind of work out well together. So we're going to start with tree diagrams. Now tree diagrams are basically exactly what we've been doing. It's just a way to visualize all the possible outcomes. Now if you recall, an outcome is just the answer to whatever you did. So the outcomes for tossing a coin are heads or tails. The outcomes for rolling a dice would be 1, 2, 3, 4, 5, or 6. So it's just the possible answers that you could get. So we're going to create a tree diagram, with an example problem. So our example today says, what are the possible outcomes for a family having 3 children? So we're wanting to see what are all the possible different outcomes we can have when there are 3 kids. So we're going to start with child 1. Now we know that their first child is either going to be a boy or a girl. So we're going to start there. So we have child 1 being either a boy or a girl. Right? Those are the only 2 options. That's all it is. Okay? So after they have child 1, they have another child. That child could either be a boy or a girl. Now how we're going to show this is that under each type, there's another chance. So if they started off and they had a boy, their next child could either be a boy or a girl. But if they started off with a girl, their next child could also either be a boy or a girl. Then we're going to look at child 3. It's going to be the same idea, except there's going to be a lot more involved. So after they had a boy and a boy, now they can either have another boy or they can have a girl. You want to make sure you give yourself plenty of space for this. Now if they have a boy and then a girl, they can either have another boy or another girl. I'm just going to use B and G because we know what they mean and I'm running out of space there. Now, if they started off with a girl and then had a boy, they could either have another boy or girl. And then if they had a girl and then another girl, they can have a third girl or they can have their first boy. So these are our options. They're having 3 kids. They could either have a boy, and a boy, so 3 boys. They could have a boy, a girl, and a girl. Or they could have had a boy, and a girl. Or a boy, a girl, and a boy. See, this shows us all the possible different outcomes that they ever could have had. So there are 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Hint, that's a trick. We're looking at all the different ways that you could have if you draw your tree and look at the last limbs. If you count up all the different possibilities there are on the last limb, that will tell you how many different possibilities there are. So we have 8 possible different possibilities for them to have had. So now let's look at, what does this even mean? What are the possibilities that we're even looking at here? Well, these parents don't care exactly what order they have boys and girls in. They just want all boys. So let's look at all the different possibilities where they can have all boys. So we're going to look at it as a probability model. So I'm going to draw my table here. If you don't remember what a probability model is, it is just something to help us see what the chances are, what the probabilities are for each different outcome. So we have our different outcomes up in the top. Then we have our probabilities at the bottom. So our first possible outcome is 0 girls, or all boys. Okay, so now let's look at where we have 0 girls. Well, we have 0 girls there. So I'm going to just circle that for myself. Is there any other time that we have all boys? Well, none of those work because that starts with the girl. So, no, that is our only possible way. We said there are 8 possible outcomes, so I'm just going to write that at the bottom so I remember. And if there are 8 total, but just one possibility where they have all boys and 0 girls, then I know that my probability is 1 out of 8. So there's a 1 out of 8 chance that if they're having 3 kids, they'll have all boys. Let's check out the next chance. I'm going to swap colors here. We'll go with pink. So now what if they just want 1 girl? So now we just have 1 girl. 2 boys, 1 girl. So let's see where we even have that. So we have a boy, a girl, and a boy. Well, that works. I'm going to circle that. We have a boy, and a girl. That's going to get real messy real quick. Well, that leads to 2 girls. We have a girl, a boy, and a boy. Well, that's 1 girl. We have a girl, a boy, and a girl. No, that doesn't work. A girl, and a boy. No. A girl, and a girl. That definitely doesn't work. That's 3 girls. So we have 1, 2, 3 possibilities out of 8 total to have just 1 girl. So our probability for that is going to be 3 out of 8. Okay, let's move on to the next chance that we have here. Well, we have 0 girls, we have 1 girl. Let's look at what 2 girls is. Okay, so we have that, we have a boy, a girl, and a girl. That would be 2 girls. We have a girl, a boy, and a girl. That would be 2 girls. We have a girl, and a boy. That's also 2 girls. And we have a girl, and a girl. Well, that's 3 girls. That's too many. So now let's see. We have 1, 2, 3. Again, we have 3 possibilities to have 2 girls out of 8 possible. So I'm going to write my probability with my desired over my possible. So I have 3 out of 8 total. Now finally, you're probably already able to see it. We're going to look at how many ways we can just get 3 girls. We don't want any boys. So come over here to our model. We want 3 girls now? Well, all these are crossed out already. We have girl, boy, boy, girl, 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 girl. That right there is the only thing we have left. All of our others are already done. So we have 1 way to get 3 girls out of 8 possible ways. So we're going to write that as 1 out of 8. So now if we look at our probability model, to get 0 girls, they have a 1 in 8 chance. To get 1 girl, they have a 3 in 8 chance. To get 2 girls, they have another 3 in 8 chance. Or to get 3 girls, they have a 1 in 8 chance. So, for a family to have 3 children, they're probably going to have at least a girl, right? Because to have 0 girls, that's like a 1 in 8 chance. It could happen, but it's more likely that they'll have some other number of girls, right? So, this is how you create a tree diagram. Again, you're going to start off with your question, and then you're going to draw branches. Now, you might have more than 2 branches. You might have 3 or 4 or 5, depending on what's going on in the scenario. You might just have 2 trials over here on this side, but you might have 7. Kind of just depends on what you're doing again. We could have had a lot more if they wanted more than 3 children. And that probably would have led to more than 8 total possible outcomes too. But here we are, 8 outcomes, and we know what all of the possibilities are. So those are kind of the good things about drawing tree diagrams, is it's a really good visual for you to see what all the different ways they can happen are. So that would be tree diagrams. Now we're going to talk about compound events. Now, compound events are events where there are 2 or more things going on, and you talk about them as either and or. So those are your key terms. And I'm going to go ahead and write those up here. Because those are super duper important. So, we're talking about compound events. We have and, or. Those are going to be the things connecting them. So you could say the probability of pulling out a red t-shirt or a blue t-shirt. So that would be a compound event. You can also talk about the probability of drawing out a red t-shirt and white socks. That's another different type of compound events. Now, when you're looking at compound events, they kind of happen a little bit differently. You kind of figure out what your probability is depending on and or. It's a little bit of a different method. We'll talk about that a little bit more probably in future math classes. But this is where we're going to start. So we have an example problem, because typically examples, at least for me, that's the best way to learn. So we are going into a pet shop. This pet shop has 6 cats. It has 4 dogs. It has 1 snake. It has 3 rabbits. And it has 6 birds. So they have 6 cats, 4 dogs, 1 snake, 3 rabbits, and 6 birds. It's kind of a busy pet shop. They got lots of different things going on there. So, let's talk about how many different pets are even available to be adopted. Grab a nice handy brown marker here. So, our total number, which we're just going to add up all the different ones, we have 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 plus 6, that gets us a total of 20 possible animals. That's how many animals they have up for adoption right now. And that means that our possible outcomes is going to be 20, so our denominator of whatever we do is going to be 20. You might want to keep that in the back of your mind. So, let's make a probability model now. Make sure we make this nice and long, so we have lots of room for all of our animals. So we have our outcomes up top. So just going to go ahead and get the rest of the boxes ready. So we have cats, we have dogs, snakes, we have rabbits, and we have birds. Okay, so now let's look at our probabilities here. What is the probability of getting a cat when you go in? So say you just go in and you're going up to the person and you say, just give me a random pet. Well, what is the likelihood that they would give you a cat? So they have 6 cats out of all 20 of their animals. So you know that you can get a cat. It's a 6 out of 20 chance. Now we can simplify that. We can divide 6 and 20 both by 2. So 6 divided by 2 is 3. 20 divided by 2 is 10. So there's a 3 in 10 chance, or a 6 in 20 chance, that you go in, randomly ask for a pet, and they give you a cat. So now let's talk about dogs. They have 4 dogs, so you know that there's a 4 in 20 chance. You can also simplify that. Divide them both by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. So there's a 1 in 5 chance, or a 4 in 20 chance, that you go in and they randomly give you a dog. Now what about snakes? They only have 1 snake. So you know that there's only a 1 in 20 chance that they'll give you a snake. Can't really simplify that. That's as simplified as it can be, so we'll move on to rabbits. They have 3 rabbits. So there's a 3 in 20 chance that you go in and they randomly give you a rabbit. And then birds, well, if you think back to how many cats we had, it's going to be pretty similar, considering it's the same thing. So they had 6 in 20, which we simplified down to 3 out of 10. So again, there's a 6 in 20 chance, or a 3 in 10 chance to get a bird. So that is our probability model for our pet shelter. So let's look at whether this is uniform or non-uniform. So if you think back, we talked about uniform and non-uniform a bit ago. So a uniform model would mean that there's an equally likely chance of getting anything. Non-uniform is the opposite. So non-uniform would mean that there might be more of a chance of getting something over another. So if we look at this, are they equally likely to get the same thing? Are we equally likely to go in and ask for a random pet and they give us a snake versus a cat? Well, no, not really, because they only have 1 snake, but they have 6 cats. So maybe they're trying to even out what they have and they give you a cat instead of a snake. Or maybe they're trying to get rid of their snake and so they give you the snake instead. You don't know that. But if they're randomly picking it, you're probably more likely to get a cat. So we know that this is non-uniform. Now let's talk about the probability that the next pet that's adopted is a cat. Well, we know that they have 3 out of 10 or 6 out of 20 chance to just randomly pull a cat out. So what is our probability? Well, a lot of times when we're talking about probability, we don't always talk about it as a fraction. Sometimes we talk about it as a decimal or a percent, kind of depending on what you are looking at. So today we're going to talk about it a little bit as percents. So we have a 3 in 10 chance to get a cat. Well, what is 3 out of 10 when you make it into a percent? Well, we can write it like this. We can add a 0 to the end of each of those and make it a 30 out of 100 because a percent is out of 100. And now, well, we have 30 out of 100. That is a 30% chance of the next person getting a cat. Let's look at snake. How are we going to do that? Now we can't really add a 0. because we have a 1 in 20 chance. If we add a 0, then we'll have 10 out of 200. Percents aren't out of 200. So we need to make this 20 become a 100. Well, how do we do that? We multiply it by 5. Remember that what you do to one side of the fraction, you have to do to the other. So that becomes 5 out of 100. So there's a 5% chance that the next person that walks in asks for a snake. What about dogs? We had a 4 out of 20 chance. We're going to do the same thing. Multiply each part by 5 to make our denominator equal 100. 4 times 5 is 20. So we have a 20% chance that the next person that walks in gets a dog. This is basic probability. This is the simple probability we were doing before. Let's talk about compound probability. So compound probability is going to be using that and, or. So let's talk about it using or. I'm going to put that off to the side so we remember that's what we're doing. Let's say that they're coming in and they're either getting a cat or a dog. Well, how many cats do we have? We have 6 cats. And how many dogs do we have? Well, we have 4 dogs. So how many cats and dogs do they have? Add them up. You have 10 cats and dogs. Okay. Well, out of how many possible animals? It was 20. 20 possible, or 20 total. So now if someone randomly came in and said, I want either a cat or a dog. So they go up and they ask randomly for a pet. There is a 10 out of 20 chance that they're going to get either a cat or a dog. We're combining those two. It's talking about union. We're putting them together and we're seeing what's the probability of getting either one of them to happen. So we are combining them. So this is what we're talking about when we're talking about compound probabilities. Using or is something that you're going to use a lot more often, at least in lower level math. You're going to see the and a little bit in higher level math because it's not just the basic adding and sticking it into the fraction. There's a little bit more that goes into it. And so right now we're just going to stick with the or because that's lower level. So that is all for today. We talked about tree diagrams and making sure that you are connecting each branch properly. We also talked about compound events using and or. Specifically today we talked about using or and how you just really have to do the addition there. And I hope you tune in tomorrow. We will talk about inferences and random samples and using censuses. So have a good day and thank you.